In the world of explosive power, two titans reign supreme: the atomic bomb and the hydrogen bomb. These weapons of unimaginable destruction have haunted humanity since their inception, but which one packs the bigger punch? The answer lies in the heart of the atom itself, where we unlock the secrets of fission and fusion. Our journey begins with the atomic bomb, a weapon born from splitting the atom, a process known as nuclear fission. But science didn't stop there. Researchers delved deeper into the heart of matter, unlocking the secrets of nuclear fusion, the process that fuels the sun itself. This breakthrough gave birth to the hydrogen bomb, a weapon of unparalleled destructive force, dwarfing its atomic predecessor. Join me as we unravel the mysteries of atomic and hydrogen bombs, comparing their inner workings, historical significance, and the sheer scale of their destructive power. To understand the atomic bomb, we must first venture into the invisible world of atoms. Atoms, the building blocks of matter, hold the key to unlocking unimaginable power. At the heart of every atom lies a nucleus where protons and neutrons reside, bound together by the strong nuclear force. Nuclear fission, the process that drives the atomic bomb, occurs when a neutron strikes the nucleus of a heavy atom, such as uranium or plutonium, shattering it and releasing immense energy. This energy release is the essence of the atomic bomb, capable of leveling entire cities in a blinding flash. But the atomic bomb was just the beginning. Scientists sought even greater destructive potential, leading them to the heart of the sun, where the secrets of nuclear fusion awaited. The world witnessed the terrifying power of the atomic bomb firsthand in August 1945, when the United States unleashed this devastating weapon upon Hiroshima and Nagasaki. The bombings instantly killed tens of thousands of people, leaving behind a trail of devastation and suffering. The bombs, nicknamed Little Boy and Fat Man, vaporized buildings and people alike. The blast waves leveled entire city blocks, leaving behind unimaginable destruction. In the aftermath, radiation sickness claimed countless lives, leaving a legacy of cancer, birth defects, and genetic damage. The atomic bombings serve as a stark reminder of the horrific consequences of nuclear war, marking a turning point in human history. If the atomic bomb marked a terrifying new chapter in warfare, the hydrogen bomb represented a quantum leap in destructive power. While the atomic bomb relied on fission, the hydrogen bomb harnesses the energy of fusion, a process that unleashes far greater destructive force. Imagine the sun, powered by the fusion of hydrogen atoms, scaled down and unleashed on Earth. The hydrogen bomb, also known as a thermonuclear bomb, utilizes a two-stage process. An atomic bomb triggers a fusion reaction in a secondary stage containing hydrogen isotopes. The heat and pressure generated by the fission reaction force the hydrogen atoms to fuse, releasing an unimaginable amount of energy. With the hydrogen bomb, humanity unlocked a new level of destructive power, threatening to extinguish life on Earth. To understand the awesome power of the hydrogen bomb, we must delve into the heart of the fusion reaction that fuels it. Fusion, the process that powers the sun, occurs when two light atomic nuclei combine to form a heavier nucleus, releasing tremendous energy. In the hydrogen bomb, deuterium and tritium, heavier forms of hydrogen, are forced together under intense heat and pressure. This forces the nuclei to overcome their natural repulsion and fuse, forming a helium nucleus and releasing a neutron. The energy released by a fusion reaction is orders of magnitude greater than that released by a fission reaction. The hydrogen bomb exploits this difference in binding energy to unleash its devastating power. By fusing hydrogen isotopes, it taps into a source of energy far greater than anything found in nuclear fission. The world held its breath on November 1, 1952, as the United States detonated the first ever hydrogen bomb, codenamed Ivy Mike. The test, conducted on the remote Enewetak Atoll, unleashed a force of destruction never before witnessed. Ivy Mike yielded an explosion equivalent to 10.4 megatons of TNT, more than 500 times the power of the Hiroshima bomb. The blast vaporized the entire island of Alujilab, leaving behind a crater a mile wide and 175 feet deep. The mushroom cloud soared to a height of 25 miles, spreading radioactive fallout across a vast area. Ivy Mike was a terrifying demonstration of the hydrogen bomb's destructive power, ushering in a new era of high-stakes nuclear brinkmanship. The development of the atomic and hydrogen bombs marked the beginning of the nuclear age, characterized by technological advancement and the constant threat of nuclear annihilation. Let's take a brief journey through the history of nuclear weapons development. 1938, German scientists Otto Hahn and Fritz Strassmann discover nuclear fission. 1942, the United States launches the Manhattan Project. 1945, the United States conducts the Trinity test and drops atomic bombs on Hiroshima and Nagasaki. 1949, the Soviet Union tests its first atomic bomb. 1952, the United States tests the first hydrogen bomb, Ivy Mike. 1961, the Soviet Union detonates Tsar Bomba, the most powerful nuclear weapon ever tested. When discussing the destructive power of nuclear weapons, the term yield takes center stage. Yield refers to the amount of energy released by a nuclear explosion, typically measured in tons, kilotons, or megatons of TNT equivalent. The atomic bomb dropped on Hiroshima had a yield of approximately 15 kilotons, while the Ivy Mike hydrogen bomb test yielded 10.4 megatons. This means that Ivy Mike was roughly 693 times more powerful than the Hiroshima bomb. The primary effects of a nuclear explosion include a blast wave, thermal radiation, and radiation poisoning. These effects, combined with the long-term consequences of nuclear fallout, highlight the truly horrific and lasting impact of these weapons. While the immediate effects of a nuclear explosion are catastrophic, the long-term consequences of radiation exposure pose an even more insidious threat. Nuclear fallout can contaminate vast areas, posing significant health risks to humans and the environment. Exposure to high levels of radiation can damage cells, leading to acute radiation sickness and increased risk of cancer, birth defects, and genetic mutations. The Chernobyl disaster of 1986 serves as a stark reminder of the long-term health and environmental consequences of radiation exposure. The radioactive isotopes released in nuclear fallout can persist in the environment for decades, contaminating soil, water, and food chains. The long-lasting effects of radiation exposure underscore the importance of preventing nuclear war at all costs. In the ultimate showdown of destructive power, the hydrogen bomb reigns supreme. Its ability to harness the energy of nuclear fusion makes it far more powerful than its atomic cousin. While atomic bombs rely on fission, hydrogen bombs fuse atoms together in a chain reaction that dwarfs the power of fission. This difference in energy release translates to a stark contrast in destructive potential. The largest hydrogen bomb ever detonated, the Soviet Union's Tsar Bomba, had a yield of 50 megatons. The destructive power of these weapons is difficult to comprehend, capable of obliterating entire cities and leaving behind a legacy of radiation and suffering. The only true solution lies in pursuing peace, diplomacy, and disarmament, ensuring that these weapons are never used again. Thank you for joining us on this journey into the heart of atomic and hydrogen bombs. We've only scratched the surface of this complex and consequential topic. If you're eager to delve deeper into the science, history, and implications of nuclear weapons, be sure to subscribe to our channel for more insightful content. Together, let's continue to explore the world around us, unraveling its mysteries and advocating for a safer and more peaceful future. Don't forget to hit that subscribe button and ring the bell to stay updated on our latest videos.